distinguish the statistical analysis of statistics for one variable, graphs for one variable, statistics for two variables, graph for two variables. And we will distinguish clearly between nominal and scale variables. As I told you before, ordinal variables usually are considered nominal variable, except when they have many values, with many meaning more than 5, in which they are somehow considered scale variables. Okay, let's before going on, I suggest you to finish filling in all the variables of the questionnaire and putting in at least 20 values, 20 questionnaires. You will find them online. I will upload as soon as you yourself fill them. You can say, I have better ways to waste my time, and I will say, well, I learned how to put inside variables, filling manually in questionnaires in. Okay, so do whatever you want. I suggest you to finish the structure completely, okay, including this structure here, which requires 4 variables, which is the most interesting one. Okay. When you finish, you will have a structure which will be hopefully very similar to the one that we are going to load now. So now I clear up everything. A little trick to clear up everything: type this strange thing, rm list equal ls, and put all the strange parentheses. Okay, it's not required at exam. This will clear up everything. Okay, now I ask you to load a workspace. Okay, where is load workspace? Oh, it's not here. Okay, you have to go to the console. It's here. I have put in your portable, or in my portable, if I can find it. Choose for example. Oh, finally, I have put in my portable sleep questionnaire.rdata. Okay. During the course, I will update it with the answer that you will give me. So it's an data. I open the workspace. Okay. Now let's go into our commander. Our commander still displays that the data set in use is my 4th, but it's not true. Okay. Oh, I must pick sleep questionnaire. Okay. So be sure that it's my sleep questionnaire. I remind you that there may be several data sets inside R. Only one of them is loaded inside our commander. Well, if you remove the data set, however, with this little instruction, our commander does not realize it. So you have to manually tell him, warning, I have removed the current data set, please change it. Okay, now it's sleep questionnaire. So you can see it's the questionnaire that we have seen here. Okay. I have filled in, how many? 271 people. No, it's not true. I have downloaded them from the web. Okay, these are real answers. They will be mixed up with the answer that you give me. Okay, you can see some variables are factors. Some others, like health rate, fit rate, and weight rate, are ordinal, but I have left them as scale. So if you type ls.str, you can see that health rate, fit rate, and weight rate are not ordered factor. And level is an ordered factor. These ones, no. I have chosen deliberately to leave them as scale, even though they are in theory ordered factors, because they are ordinal variables, because in this way I can use them as scale variables. You can do different things with scale variables and with nominal variables. So pay attention when choosing how to classify an ordinal variable. If you decide that it's an ordered factor, R will let you do only things which are available for factor and not things which are available for num. Okay, so I have left them as they are, and they've been written as atomic, means number without comma, basically. Okay, same thing for the other one here, sat sleep. Okay, while quality sleep, it's an ordered factor with 6 levels. Okay, very poor, poor, etc., etc. Okay, so after having loaded it, let's see what can we do. Summaries. Okay. First of all, we have summary statistics, which are basically descriptive statistics, which displays how the variable is built. It's mandatory, and I repeat, mandatory, okay, to apply it to all, and I say all, the variables of the data set, because it's the only way for you to spot all the many mistakes that for sure you will have made. Okay. This data set, I hope it's without mistakes, but at exam, I may give you deliberately some data sets with mistakes, and if you don't spot them, it's bad for you. And I can assure you that many statistical analyses don't get good results because they are full of horrible mistakes. You have different statistics for scale variable and for nominal variables and ordinal considered nominal. Okay. Let's see. Start with the scale variable. For scale variable, the statistics are the usual one. Average, standard deviation, variance, minimum, maximum, range, quartiles, or quartiles. Let's see how to get them. Statistics, summaries, numerical summaries. Oop. You choose the variable or the variables, in this case all of them. Well, let's concentrate on age. Okay. You can choose which statistic do you want. Well, usually mean means average. Standard deviation, interquartile range, and quantiles are fine. Okay. Skewness and kurtosis we'll see later. Okay. But rest honestly. So the default choice is good. Okay. And you can see here that for age, we have an average age of 43.87097. By the way, whenever you type something in a paper, in a journal paper, or in your thesis, please don't say the average is 43.87097. And don't even say the average is 43.87. Saying the average is 43.9, it's enough. And I will say the average is 44. Okay. So it's worthless to give 3000 decimal digits because the statistical program gives them the decimal digit. Standard deviation. If you don't know what is standard deviation, I remind you that it is a prerequisite of the course. I remind you that, where is it? Prerequisite, have not yet uploaded it. Okay, however, it will be uploaded as a prerequisite of the course. Okay, interquartile range. If you don't know what they are, look in Wikipedia. These are the quartile. So 0 means that the minimum value is 18, and I am relieved. It means that we don't have 3 years old children answering the questionnaire. It means that the youngest 25% of the people stays between 18 and 34, and the oldest 25% of the people stays between 54 and 84. The oldest one is 84. This is the median, okay, 44. So mean 43, median 44, well balanced questionnaire. How many people you have? 248. And 23 people don't tell us their age. So we have 23 not answer. You can see, not answer, not answer, not answer, not answer. Can I close it? Okay. Okay. Now, let's do another one, just alcohol. How many alcohol drinks do you... Oh, let's smoke num, which is more interesting. Okay. How many cigarettes do you smoke? We have a mean of 13. Okay. 25% of the people who smoke less stays between 0 and 5. The top 25 stays between 19 and 78. Okay. We have, however, only 35 people who answer. Okay. 236 people don't answer, probably because they don't smoke. Okay. This is one of the typical mistakes, let's see, that you can easily spot. First of all, if you see somebody who says, I don't smoke, and then writes here 3, well, it's evidently wrong. Either this one or this one. But also here, this one says I don't smoke, and smoke num is NA. Well, it will be better if it were 0. On the other hand, I imagine we have for sure. No, we don't have anybody writing 0. Ah, okay, look at this person. He says that he doesn't smoke, and then he correctly types 0. Mm. So here you have to choose. Either you type NA for all the people who don't smoke, or for all the people who don't smoke, you type 0. Okay. So this is one of the little mistakes that, let's say, of the difficult mistakes that you can spot. There are much easier mistakes that you can spot. For example, if here in age you see 3, a minimum age 3, well, it's evidently a mistake. Okay. Or if you see that there is an average of 43 and a median of 25, the ones of you who have knowledge of statistics knows that if the average and the median are very different, the distribution is very skewed. Okay. So you do it for all the questions, trying to see, especially in the minimum and the maximum, whether there are strange things. For ordinal and nominal variables, you choose instead frequency distribution. For example, at the level, which is an ordinal variable. It tells you that there are 3 people in primary school, 33 secondary, 30 trade school, 71 undergraduate degree, 132 postgraduate degree. The percentage are 1.12% to the primary school, 26 the undergraduate degree, 49 the postgraduate, etc., etc. Half the people do the postgraduate degree, have a postgraduate degree. Very strange, very unbalanced. Okay. This is helpful for 2 reasons. First, if you see that there are people with value 6, so this value 1, this value 2, this value 3, value 4, value 5, if there are people with a value 6, well, there are evidently some mistakes. Okay. Second, you can see that half of your people have a postgrad degree. Your sample is a little screwed up. It's a little biased towards the most educated people. Okay, let's take another one. Bruxism. Okay. 23 yes, 227 no. 9% of the people have bruxism. Well, fine, this is fine. You can see if there is a yes, no, 3, another value of another number, well, there is a problem. Okay. I think that if you choose active data set, you will get all this for all the variables without too much effort. Let's see. 29 variable, yes. Well, ID, sex, yes, it's a condensed version, so you cannot choose which statistics, but it will display the minimum, the first quantile, the median, the mean, the third quantile, the maximum. Sex will display instead the frequencies, so according to the type of variable will display different things. Age, Marisha will display only the frequencies. Well, this is a good way to do it fast for all the variables, if you want to look at everything here. Okay. Graphs for one nominal variable. Okay, let's start here a sort of theoretical thing. Okay, which graph do we have available for one nominal variable? Well, the basic one, the one that you should use unless you have very, very good reason for using another one, it's the column plot. There is no discussion on this. This is an example of a column plot. It's millions of patent applications in Japan, US, and Europe between 1998 to 2007, if you're curious. Okay, you can see you display how many data do you have in columns. Okay, so here you have a data set of containing 9 millions of cases. Of these 9 millions, 4 millions have Japan, 3 millions have US, and 1 million have Europe. Okay, and you display the frequencies, so how many Japan, how many US. It's exactly, I say exactly this thing here. Where is it? This thing here. Single, married, divorced, widow. exactly, it's the graphical version of this graph here, nothing else. Okay, if you have very good reason, you can use one of these two graphs. Okay. Pie chart usually makes sense when you want to point out percentages more than numbers. These are the numbers of attending people to a workshop on social media 2011, and these are the number of shops open on weekdays. So this I want to point out the fact that the Hispanic were the largest percentage of participants, followed by Black, followed by White, followed by Asian and Native Americans. Okay. In extremely, and I say extremely rare cases, you can use the radar graph. The radar graph is exactly like this one, but instead of displaying the data in columns, you display the data in, let's say, sectors. Okay. It's useful whenever your categories, here your categories are Japan, US, and IPO. Okay. Whenever your categories have a circular meaning, so after the last category, the first one comes back. Usually time or geography points. I don't figure out any other possibility. Okay. So you can see here clearly that the number of shops open rises from Monday to Tuesday and remains more or less the same, drops to Saturday, probably it is the shops in Bolzano, drops down almost to zero on Sunday and takes up on Monday and again. Okay. However, very rare cases. In R, I anticipate to you that you can do this one and the pie chart. You cannot do this one. You have to go to Excel to do it. Okay, other alternative graphs. The bar plot. Do you notice any difference between the bar plot and the column plot? Well, no. There is no difference except for the aesthetic. Okay. So the bar plot, I don't even talk about it. It's ridiculous. Okay. Line plot. Also the line plot, it's identical to a bar plot in which the bars have been replaced by points connected with a line. It makes sense only if the variable on the horizontal axis is time. Otherwise, it doesn't really make sense. Otherwise, the best choice is always the column plot. Area plot. Do you notice any difference between the area plot and the line plot? No difference at all. Okay, so they are the same. Finally, all the three-dimensional variants. Please, they are silly, ridiculous, non-professional. Okay? If you open any magazine, you will find three-dimensional graphs everywhere. Well, whenever I see a three-dimensional graph, I imagine that the person had nothing else to say and has to do some three-dimensional effects just to capture my attention. Okay, there is no reason to use a three-dimensional graph for one variable. Okay, there are few reasons to you do it for two variables, but absolutely no reason for one variable. Look here, this could be a column plot without any problem. There is no reason to make three-dimensional, especially because when it's three-dimensional, you don't see very well. For example, you don't see whether Ottawa is more than Vancouver or not, because the three-dimensional confuses the things. Okay, let's see which graphs are available in R. As I anticipated to you, only the bar graph, which is the column plot instead, and the pie chart. Okay, let's see. Graph, bar graph. Let's build a bar graph for Marischal. So, Marischal. You can put some labels, or if you want, you can leave auto. But let's put Marischal status, frequency, graph title. Press OK, and here you have the graph. Pay attention, the graph does not appear in R Commander, but appears next to the R console. So if you are in R Commander, you may have to switch the window. Sometimes it switches automatically. Okay, you can see the graph. Well, doesn't look like a masterpiece, especially because there is one category completely missing because Mary Defector has overwritten it. Okay. I must be honest, Excel is much better at building graphs. followed by SPSS. R, it's usually a disaster with graphs. Okay, however, this is your graph. If you ever want to export it into Word, don't try with file or oops, with strange things. The best choice is right click, don't save, copy as bitmap, open your Word, well, maybe a new file, and you can paste it. So you paste it into Word. It will be pasted as an image. So you will have few ways to change it. You can change only background, put strange things, but okay, you cannot do anything else. Okay, or you paste it to your favorite image editor, Photoshop or Paint, and then you try to change some little things. Okay. Now, please remember always to close the graph, otherwise you will have problems when opening another one. Okay. What happens if you would like to remove that horrible gray color for the bars and prefer a more vital red or yellow? Okay. You have the color palette here, okay, which tells you which colors are used by R. Okay. So the first color used by R should be black. I don't understand why the bar graph results in being gray anyway. First of all, if you want to change the order of the colors, you can decide to do it yourself. However, this color number 1 for R, this color number 2, number 3, number 4, number 5. For example, if you prefer yellow as number 5, you just go here. Okay, now yellow is my number 5. Okay. Now in my palette, yellow is my number 5. Okay. Now, how to force R to use, for example, red, which is color number 2 in my palette. Okay. You can see the last time we asked for a bar plot, R has written this strange thing. Okay. You don't care about the strange thing, but paying special attention to parentheses, you can see there is a bar plot open parenthesis here, table xlab, ylab, main. You go on with comma, col equal C1. Okay. The last space is not necessary, I put it only for readability. It means that the color used are, don't worry about the C, 1. Okay. Let's see, I select it and resubmit. And now I got a graph using the first color. The first color in my palette, finally, if you put it large, it will show also divorced. The first color in my palette is black. Okay, if you want to have a more rainbow effect, use 1, 3, 2, 5. Okay, if I remember correctly, it should be black, green, red, and yellow. Let's see. I select it. Wonderful. Okay. So if you specify only one color, it will use only that color. If you specify several color, it will use several color. So you have this little trick of adding this instruction. Pay attention to where you add it. You must find the among this chaos. You must find the command which tells you exactly which kind of plots are you doing. Okay, let's see the pie chart instead. Let's do the same, Marichal, but with a pie chart. Always Marichal. Where is Marichal? Okay, this time I don't put any x's. Okay, well, nice, and it uses almost good colors. Okay, if you don't like the colors, you just specify them with C. Let's see, this was the thing used. You can see here there is a col equal rainbow, blah, 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 blah. It means that the colors are taken from a rainbow. If you don't like it, you can change it. Here, pay very attention to parentheses. 1, 2, 3. So 1, 2, 3. And I, 3, I say. And I remove this thing. And now here, see, 1, 3, 2, 5. Okay. So pay attention to parentheses. The parentheses that are open must be closed. Don't blame the computer during the exam. Okay. Wonderful, eh? You can copy as bitmap and paste it inside Word. Oop. An horrible graph. Okay. Okay, so to change the color, use this trick, pay attention to what you do. Let's go on. There are some little exercises here if you want to use them. But let's go on to graphs for one scale variable. Okay, some theory. This traditional graph for one scale variable is an histogram. It's the histogram. What is this? Imagine you have a scale variable, so a variable like age. You have 3,000 people, each one tells you a different numbers. Okay? Or you have a variable called weight. You have 3,000 people, each one states a different weights, sometimes with commas. Okay? So you have a continuous quantity of numbers, okay, that you cannot represent as categories. Okay? You must somehow group. This is an example with income, monthly income. If you ask people for monthly income, for the exact monthly income, so you take them from the official paper, okay, they will answer with a lot of different values. If you build a column plot, most of them will be 1, because if somebody earns $2,023, another one earns 2,024, these are two different numbers. In order to build a meaningful graph, you have to group into bins. It means that you have to group, for example, everybody from 1,000 to 1,200, everybody from 1,200 to 1,400. So you have to build bins and group them and count how many people fall into that bin. This is exactly a questionnaire. So for example, here we can see that there are 2 people which earn between 1,000 and 1,500. Other 7 people which earn between 1,000 and 5, no, it's 1,300. Between 1,300 and 1,600. There are 12 people which earn between 1,600 and 2,000. There are 14 people probably which earn between 2,000 and 2,300, and so on. So you have to group into bins. Clearly, the shape and the resulting graph, the shape of the histogram and the resulting graph depends a lot on how do you choose your bins. First of all, this is my personal rule. Never, and they say never, choose bins of different size. You can see here all the bins have the same size. Here I've taken the first the first bin goes from here, from 0, let's say, to 1,300, and look what happens. There are inside 4 people, 5, 6, 7, 8, here 7, 8. So if you take bins which are larger than the others, clearly more people will fall into that bin, and here's the resulting thing. So taking a bin larger than the other can skew the entire histogram. So never have bins larger than the others, okay, because they are cheating. Okay. But also, please avoid having too large bins, because if your bins are too large, they don't display the real distribution. Look at the real distribution here is having a peak here, another peak here, and then sharply decrease. Okay. Here I'm taking 2 large bins with $1,000 large wealth, and so it's not appropriate. And even don't commit the opposite mistake. 2 small bins. Here I have 2 small bins. I have several bins with 1 person and several missing. So you have an up and down effect. Okay. So the choice of bins is crucial. Not too few, not too many. For sure, never have bins with different sides. Okay. So you can, for example, try. You can try if you see an histogram like this one. you choose less beans. If you see an histogram like this, so you choose more beans. It's pretty easy. There are some rule of thumbs, like the beans must be the logarithm of the number of cases, but you can try. I usually try with 10, then I raise or decrease it according whether the graphs look like this one or like this one. Okay, histogram can be built with R. Okay, well, let's go straight forward to histogram so you can graphs, histogram. For example, an histogram of age, options, number of beans. Okay. Well, let's leave it out. Please use frequency counts always, or otherwise it will create strange things. So let's leave it out for the moment. Okay. Well, I think that we can try, currently the bean size is 10 years. I think that we can try to double the number of beans. So 1, 2, 3, 4, 5, 6, 7, 8. We can try with 16 beans. Statistic, graphs, histogram. Let's try with 16. Well, better. Probably this one is the best one. Okay, and now obviously I don't like these horrible gray bars. Let's put red bars. All bars red. In an histogram it doesn't make sense to have one bar red and one bar yellow. Okay, this is the histogram. You can see here col equal dark gray. Well, you can here you can say red, or you can use the technique we learned before. See, I think red is color number 2. Fine. Okay, wonderful. Okay. Again, here there are some little exercises. Remove this one, which is far beyond your abilities. Okay, let's see another type of graph which is present inside R, and it's the box plot. You have another way to display the distribution of a scale variable, and it is the box plot. It's very strange to look at it. Let's say it's only for professional. Don't publish it in a magazine, they will throw you tomato, rotten tomato. Okay, it's used only by professional, but it's very, very meaningful. Look, this is a box plot. Or if you are curious, it's the daily log return of 3M company quoted at Nasdaq in 2012. So I have 250 data, one per trading day, and I plotted the daily plot return. Okay, what does it tell us? Well, the big black line is the median. If you don't know what is a median, I remind you it's a prerequisite for this course. Look in Wikipedia. Okay, the median splits the distribution into two parts, 50% above and 50% below. It means that the median is almost zero. So it means that 50% of the days we had a negative log return, and 50% of the days we had a positive log return. Okay. Then the yellow part, the yellow rectangle, is the central 50%. This is the central 50% of the distribution. This is the second quartile, and this is the third quartile. So from 25 to 50, from 50 to 75. So you can see that the biggest part of the half of the distribution stays between minus 0.5 and let's say 0.6. Okay, so half of the cases are here in this central part. The whiskers, which are this thing here, these are called whiskers, determine the central 90%. So you can be sure if you buy 3M company at Nasdaq during 2011 that your daily log return stays between -2 and +2 with a 90% of probability. Okay. Outside you have the extremes, also called outliers. So values which are individually indicated with a dot, which are very large, very high or very low, which are outside the central 90%. So this is a box plot. Okay. Clearly, for example, you can also see here that the size of this 25% is smaller than the size of this 25%. Okay, it means that you are able to go up to 0.6, while here probably you're limited to 0.5 or minus 0.5 or minus 0.4. Okay, however, here the probability is higher. It's 25% concentrated. Here is 25%, a little less concentrated. However, you can also see that this distribution is more or less symmetric. It's slightly unsymmetric here, but not so much. Okay, let's see how to build a box plot in R. We'll build a box plot for age. Box plot for age. Options. Identify outliers automatically. Nothing else. Okay, no outlier. Well, it means that these people, even though they belong to the top 20, top outside the central 90%, are not so far away. The median is here, 44. Okay. And the central 50% of these people are between 34 and 54. So it means that our sample is very concentrated in middle-aged people. Okay. Again here, if you like it using another color, just add comma col equal C5 and it will be yellow. Yellow. Or I think it works also if you call equal yellow, but you can specify only one. Let's see. Yes. Okay. Let's see some other box plot because I understand that this for you is a strange beast. For height, okay. Well, 170, the median is very large. For weight, what is weight? Okay, here finally we have some outliers. Outliers are identified with a ID. They are identified with row names, or if you don't have row names, with the first variable, which is ID in this case. So you can see the median is about 70 kilograms. The central 50% is between 60 and 80, roughly. The central 90% is between 45, which is also the lightest one, and the 110. And then there are two outliers, and I would say one extreme. Usually outliers are the ones which are rather close, extreme are the ones which are rather far away. Probably Wikipedia gives you a very precise definition. So you can see that person 166. If this were a real questionnaire, a real work, I would investigate on person 166. Okay. So it's also drawing box plots a good idea to spot the cases which are terrible. Okay. Let's see also number of smoked cigarettes. Also there probably will find many outliers. Smoke num. Okay, one outlier, 204, which smokes almost 80 cigarettes. Okay, the rest stays well below 40. Okay, there is one last thing you can do for scale variable. Okay, in case, and I repeat, only in case your scale variable has very few values, okay, very few cases, you can plot case by case. So imagine you have a small data set with gross domestic product per capita, and you have only 1, 2, 3, 4, 5, 6, 7, 8 cases, which are United States, China, Japan, Germany, France, Brazil, United Kingdom, and Italy. Okay? So you have a small data set with only 8 cases. In this, even though GDP it's a scale variable, it's meaningless to have to build an histogram with only 8 cases. Are you going to use 3 intervals? Okay, so in this case, it's much better to adopt some graphs derived from nominal variables and display them, however, case by case. So use the cases as categories And here, instead of having the frequency, you have the number. Pay attention because it's different. Here you don't have, as usual, category and frequency. You have the case name and the value. This not doesn't mean that there are 1.4000000 United States people. No, it means that United States have a GDP equal to 1.4. Okay. In some extremely rare cases, you can do this thing. For example, average monthly precipitation in Boston. This is true, I think. Since it's a monthly thing, after December comes January, instead of doing a column plot, I have done a radar plot like this one. You can see clearly that in winter it doesn't rain so much. July is the most rainy month. Okay, it's the same thing here. This one is not the same, however, from a logical point of view as this one. Because here you have frequency, so how many cases, so how many shops are open on Monday. And here you don't have cases. You don't have three shops, what is 4 shops, no, in October. No, it's 4 centimeters of rain in entire October. Okay, let's now see how can we do it in our commander. Unfortunately, we don't have any variable in this data set which has few cases. Okay, because this data set, as you can see here, it's composed of several cases. And I remind you, it's meaningless to do this kind of technique on a scale variable if you have more than, let's say, 10, maximum 15 cases. In this data set, we have already 271. So now, as an exercise, we will import this very small data set in Excel. So data, import data from Excel. Let's call it my sixth import. Choose sheet 2. Sheet 2, we had the small one. Okay, let's take a look at it. Oh, it's small enough. Let's display, for example, variable C, which will have values 7, 9, and 5. So, graph, index plot, variable C, choose points, done, 7, 9, and 5. Observation number 1, observation 2, and observation 3. Okay. Clearly, without observation names, it doesn't make sense to match observation 1, observation 2, observation 3. Okay, let's use spikes. Okay, so observation 1 is 7, observation 2 is 9, observation 3 is 5. Unfortunately, in these basic tools, you can complain that it doesn't look like this one. Okay, well, but this one was done by Excel. This one was built by R. You can't have anything better. Unfortunately, also you cannot start from 0, as it would be much better, so you can get a look of this 5. Okay. However, this is the little trick to build something like this using I repeat, using a scale variable with few cases. Okay.